It seems like there's always some new piece of evidence put forward to claim that life could have existed on Mars. To help us tell fact from science fiction, scientists and engineers involved in the ExoMars 2020 program discuss the latest on the search for life on Mars. Museum scientist and Martian terrain expert Peter Grindrod is part of the ExoMars team that will be capturing and analysing new footage of the red planet. He believes that Mars is the best place to look for life outside of planet Earth, but admits that finding and proving it isn't going to be easy. ExoMars 2020. The primary goal of the upcoming 2020 ExoMars mission is to look for evidence of life on Mars, extant or extinct. After escaping Earth's atmosphere in a proton rocket, the rover will make a 9-month journey to enter the orbit of Mars. It will then parachute down and, aided by rockets, land carefully on the Martian surface. ExoMars 2020 will be the first mission to take core samples from deep within the Martian surface. Why look for life on Mars? According to Peter, Mars is one of the most likely places we will find evidence of extraterrestrial life. The red planet's similar history to that of Earth, as well as its relatively pristine conditions, make it an ideal place to start the search. We think that Mars and Earth were probably quite similar in their early history, Peter says. Not long after the solar system formed, about 4.5 billion years ago, Mars was almost certainly wetter, probably warmer and had a thick carbon dioxide atmosphere. It would have been a reasonably habitable environment for life as we know it, and interestingly it was at almost exactly the same time that we think life was first forming on Earth. Since then the two planets have gone down very different evolutionary paths, but the chances of finding evidence of early life on Mars could be higher than elsewhere in our solar system, Peter adds. In fact, it might be easier to find signs of very early microbial life on Mars than here on Earth, where plate tectonics and the abundance of life make rocks from this time a challenge to find and interpret. Although Mars is very far away, those early rocks with evidence of life may be easier to find on Mars than on the Earth, because it is so pristine, Peter explains. What do scientists expect extraterrestrial life to look like? While Hollywood offers great fuel for the imagination, scientists think it likely that evidence of life on Mars will be very small. When we talk about life on Mars, what we are talking about is microbial life, because that's what we see on Earth at a similar time. Evidence for life about 3.5 to 4 billion years ago is primarily going to be morphological, meaning you look for patterns in rocks and supporting evidence, so that you can make the argument that it was caused by life. Searching for signs. Part of Peter's role in the ExoMars mission is to look at the geological processes on Mars, to help decide where missions should land to have the highest possible chance of encountering life. There are a number of factors that scientists look for and consider ingredients for life in space. One of the main things we to look for is long-standing liquid water, Peter says. You might look for lake deposits or chemical evidence that water was there. The presence of phyllosilicate minerals like clay can show an area not only had water present, but that there was a neutral pH, which is quite life-friendly. Sulfate minerals indicate high acidity, which is, as a general rule, less friendly for life. Life-friendly environments occur in some of the oldest rocks on Mars. They coincide with those earliest days, when it was most similar to early conditions here on Earth. But research into extreme life here on Earth has opened up discussion about whether Martian life could be more resilient to inhospitable conditions. Is there any evidence of life on Mars? Despite what the headlines might be claiming, there is no proof yet of past or present life on Mars. However, previous missions have been filled with promising signals: methane and formaldehyde. Small amounts of methane and formaldehyde have been found in Mars' atmosphere. Methane can be produced geologically, meaning without the presence of living organisms, but might be an indicator of microscopic life below the surface of Mars. Viking lander experiments. In the 1970s, the Viking program sent 2 landers to seek evidence of microbial life on the surface of Mars. Each lander performed 4 experiments, and only one experiment gave a positive result for metabolism, chemical transformations in celled organisms. Some scientists claimed that the Viking experiments provide evidence of microbial life on Mars, but these claims have not been widely accepted by the scientific community. Curiosity rover sampling. In June 2018, NASA reported that the Curiosity rover had found complex organic compounds in mudstone rocks from a dry lake on Mars. The compounds resembled precursors to oil and natural gas found on Earth. The compounds were considered proof that the types of materials needed to sustain microscopic life were present, but were not evidence that life existed on the planet. Meteorites. Several contentious claims have also been made that there is evidence of life in Martian meteorites collected right here on Earth. Allen Hill's 84,001, which was found in Antarctica in 1984, is perhaps the most famous example. This image is a close-up of meteorite Allen Hill's 84,001. The electron microscope shows chain-like structures which resemble some bacteria on Earth, only much smaller. However, scientists have found that similar shapes can be formed by inorganic processes on Mars. In 1996, a group of NASA scientists reported finding tiny nanoworms made of magnetite that they believed to be evidence of tiny bacteria on Mars. The claim was largely rejected by the scientific community on the basis that the forms could have been formed by geological or analytical processes. The rare specimen, a section of which is kept at the museum, is much older than the majority of meteorites recovered to date and continues to be closely studied. Where will the ExoMars 2020 rover land? Peter and his team have been part of an international effort to choose the best landing site for the ExoMars 2020 rover. Not only does the location need to have the best chance of finding life, it must work to a number of tight engineering constraints. The first challenge is the very thin atmosphere on Mars. For the rover to land safely, and with enough time for the parachute to slow it down, the landing site must be 2 kilometers below the average land level on Mars. Unfortunately, this will rule out almost the entire southern hemisphere, which is higher, older and might also present a good chance of finding life, Peter says. Due to the climate on Mars, the rover must also land near the equator between 25 degrees north and 5 degrees south. The rover is solar-powered, so we need to land somewhere near the equator of Mars, so that it can recharge efficiently. The temperature will only ever get to a few degrees above freezing, but can drop down to 150 degrees Celsius. The tilt of Mars is the same as the Earth, but an elliptical orbit means temperature changes are more extreme in the southern hemisphere. Within these constraints, scientists need to land the rover on a surface that is one of the oldest parts of Mars, where they can encounter rocks older than 3.7 billion years. The parameters left us with roughly 2% of the planet to choose from. The final landing site selection will take place in November 2018 with launch planned for July 2020. On the ground. In the lead up to the landing, Peter and his team will be running simulations before traveling to the rover control center based in Turin, Italy. In Turin, teams of scientists from around the world will enter a 3-month lockdown, monitoring and controlling the ExoMars rover and analyzing data. The whole operation will take place on Mars time, with each day starting 45 minutes later than the day before. Extraterrestrial evidence. If the mission successfully locates evidence of life on Mars, proving it without having the samples and labs on Earth will be quite a challenge. To use Carl Sagan's phrase, extraordinary claims require extraordinary evidence, says Peter. If the rover does find something interesting, it's possible that the evidence we get back may not be enough able to stand up to the test of proving unequivocally that life exists on Mars. It may well be the case that we're going to have to collect the samples in a future mission and bring them back to Earth in order to find sufficient proof to convince the scientific community. If we start that process now, we could have that evidence back here on Earth as soon as 2025. Apostrophe.